Picture this, a planet with no blue left on it. No waves, no coastlines, just white, stretching from pole to pole, and ocean water frozen solid, down to depths where sunlight has never once touched. Volcanoes still glow beneath that ice, the only fire left on a world that has gone completely silent. This happened on our planet more than once. This is the story of Earth's ice ages, and the story of how our world nearly froze itself into nothing. Let's step back roughly 700 million years, long before dinosaurs, long before complex life as we know it. Geologists studying ancient rock layers found something strange. Glacial deposits, the unmistakable fingerprints of ice, buried in regions that once sat near the equator. This discovery led to one of the most dramatic theories in Earth's history. Scientists call it Snowball Earth. The idea that our planet, at least twice in its deep past, froze almost entirely from pole to pole, ice covering nearly every ocean and continent on the map. How does an entire planet freeze? The answer begins with a delicate balance, one most of us never think about. Earth stays warm because of a thin blanket of greenhouse gases trapping heat from the sun. But billions of years ago, that balance was far less stable than it is today. Early plant life and ocean organisms began absorbing massive amounts of carbon dioxide from the atmosphere. Over millions of years, this steadily thinned the planet's heat-trapping blanket. As carbon dioxide levels dropped, less heat stayed trapped near the surface. Temperatures fell. Ice began creeping outward from the poles. Here is the strange part. Ice does not just sit there. It fights back against the sun. Ice reflects sunlight far more efficiently than land or ocean water. So, as ice spread, it bounced more sunlight back into space, cooling the planet even further. Cooling led to more ice. More ice led to more cooling. So here's a question worth sitting with. If ice keeps making more ice, what could possibly stop it? Scientists call this feedback loop the ice-albedo effect. And once it gained enough momentum, it may have become nearly impossible to reverse on its own. Picture standing on that frozen world. No wind moving over open water. No waves. No sound but your own breath. Just white in every direction, and cold deep enough to freeze the ocean floor. For any organism living through this, it must have felt like the end of everything. And yet, life did not end. This is where the story takes an unexpected turn. One written not by ice, but by fire. Even during a frozen planet, Earth's interior never stopped moving. Volcanoes continued erupting beneath the ice, unaffected by the frozen world above them. Slowly, patiently, over hundreds of thousands of years, these volcanoes released carbon dioxide back into the atmosphere. Because ice sealed off most of the ocean's ability to absorb this gas, carbon dioxide levels began climbing steadily, with almost nothing to stop them. Eventually, the greenhouse effect grew powerful enough to overcome even a fully frozen planet. The thaw, when it finally came, was not gentle. Scientists believe it may have happened with startling speed on a geological Timescale: plunging Earth from a deep freeze into an extreme greenhouse. Climate within a relatively short span of time. This dramatic swing from ice to intense heat may have done more than just melt glaciers. Many researchers believe this chaotic climate shift helped set the stage for one of the most important events in the history of life on Earth: the rapid diversification of complex multicellular organisms shortly afterward. In other words, the near death of our planet may have helped push life toward becoming what it is today. Snowball Earth was not the only ice age our planet endured. Over the last 2.5 million years alone, Earth has cycled through dozens of smaller ice ages, each one advancing and retreating as our planet's orbit, tilt, and wobble shifted with astonishing regularity. These cycles, known as Milankovitch cycles, altered how much sunlight reached different parts of Earth, nudging the climate between cold glacial periods and warmer interglacial stretches again and again. It was during the most recent of these cycles that woolly mammoths roamed frozen grasslands, that saber-toothed cats stalked frozen tundra, and that early humans first learned to survive brutal winters that could last for generations. That ice age ended roughly 11,000 years ago, ushering in the relatively stable climate that allowed human civilization to rise. Now, here is a detail worth pausing on. Based purely on the natural rhythm of these orbital cycles, many scientists believe that without human influence, Earth would likely be moving toward another glacial period sometime over the coming thousands of years. But that is not a simple countdown. Human-driven changes to the atmosphere are now interacting with these ancient natural cycles in ways researchers are still working to fully understand. Ice ages are not simply cold, quiet seasons in Earth's history. They are proof of how finely balanced our planet's climate truly is. A shift in sunlight, a change in a single gas, a subtle wobble in orbit. Any one of these, given enough time, has the power to reshape the entire world. Frozen oceans, buried continents, a planet pushed to the very edge of survival, only to erupt back into life through fire hidden beneath the ice. Earth has done this before, more than once, and the next great shift may not announce itself with a storm or a single dramatic moment. It may begin quietly, in changes so small, so slow, that no one notices until the ice is already moving again.